Hello everyone. In this session, we're going to understand about the addressing modes that are supported by 8086 processor. But for this, I request you guys to watch my session about the generic addressing modes. Earlier, I explained you guys about a few generic addressing modes. If you could understand them, these addressing modes will be simpler. Generic addressing modes actually are generalized to be used in any processor. They can be used in any of the processor. It could be i3, i7 or i6, but in a customized pattern. If you could understand them, these addressing modes will become very simple. Now let us understand this. When it comes to the register addressing mode, the instruction is going to specify a processor's register, such as add is an opcode followed by a processor's register. In this register, we will have an operand. This is the actual operand. We need to go to the register which is specified in the instruction, and then we need to collect the operand from that register. This is what all about register addressing mode. What is immediate addressing mode? When it comes to the immediate addressing mode, within the instruction, let us say, there will be an immediate value specified rather than a memory address or a processor's register. Now here, this is an immediate operand. This is the actual operand. This is neither a register nor a memory address. This is the direct operand. You know that? The second operand is always accumulator. In single accumulator organization, accumulator is equal to accumulator plus 240. Yeah, this is what immediate addressing mode. What is direct addressing mode? Let's have a look at. In the direct addressing mode, the instruction, within the instruction, we do have a memory address. This is the direct address in which the actual operand is available. Taking that address, going to the main memory, we can find the operand. This is the 240th location within the main memory in which we will be able to find out the operand. This is what all about direct addressing mode. But let us understand something very clearly. When it comes to the 8086, 8086 is going to support more than one operand within the instruction. It is not simply add A. 8086 may have two operands within the instruction, add A comma B. Now here we are provided with two operands by the instruction. In this case, each of the operand can have its own addressing mode which is different from the other operand. That is, both operands can be specified in different addressing modes. Okay, but when it comes to the direct addressing mode, one of the operand will be specified by the direct address. In this case, move bx comma 1354h. Bx is, you know, that the B register. To the B register, the contents at 1354 address will get transferred. H is hexadecimal. 1354 will have an equivalent binary value, which is just nothing but an address, going to which we'll be able to find out the operand. That operand will get transferred to the B register. Similarly, BL comma 0400H. The value which is at 0400 will get transferred to the lower byte of B register. Next is register indirect. What is register indirect? In the register direct, there will be a register specified within the instruction in which the operand is available. Let us say add R1. Now R1 holds the operand, but within the register indirect addressing mode, the register which is specified within the instruction holds a memory address. Now this is not an operand, this is a memory address, going to which you will be able to find out the actual operand. The register which is specified within the instruction is going to contain a memory address rather than a direct operand. This is all about register indirect addressing mode. In the register indirect addressing mode, here BX is the register which actually contains the operand. From that location, the contents will get transferred to CX. What is base addressing? You know that in the base register addressing mode, the contents of the base register will be added to the value which is provided within the instruction. There is a register called base register within the system. That register holds a value. Let us say in our case 220. There is an instruction that is add 540. In the base register addressing mode, the value which is given within the instruction should be added to the contents of the base register in order to calculate the effective address. Effective address is just nothing but 540 plus 220 in this case. 540 plus 220 is equal to 760 is the actual effective address in which we do have the operand. When we add these values both, we will get an address, memory address. We don't get a direct operand, mind you. Once again, let us understand. In the base register addressing mode, we need to add two contents. One is the contents of base register. Another one is the value which is provided within the instruction. When you add them both, you are going to get a memory address which is considered to be the effective address in which the actual operand is available. This is what base register addressing mode. So you can clearly see the value which is given in the instruction will be added to the base register contents in order to calculate the effective address. Okay, so let us say this base register is 20. This is, let us say, this is 40. 08H, let us say this is 40. It is not 40, but let us understand at this point of period that it is equal to 40. So the contents of the base register will be added to the value, that is 20 plus 40, which is 60. Now this is an address of the main memory, which is the effective address. In 60th address of the main memory, we do have the actual operand that must get transferred to AX register. This is based addressing. When it comes to the indexed addressing, apart from using, rather than using base register, we are going to use another register which is called index register. Earlier, the value which is in the instruction is added to the contents of the base register in order to calculate the effective address. Indexed addressing is similar to base addressing, but only the difference is now the value which is given in the instruction will be added to the index register rather than base register. In this case, we'll call it as a source index. The value which is given in the instruction will be added now to the index register to calculate the effective address. Base index addressing, which is even more simpler. That is, the value which is given in the instruction will be added to both source index and destination index, both source index and base register. Bigger pardon, the value which is given in the instruction will be added to two values. One is index register, one more is base register, in order to calculate the effective address. Let us say base register's contents is equal to 20. Index register's contents is equal to 40. The value which is given in the instruction is 60. 60 plus 40, 100. 100 plus 20 is equal to 120 is the effective address of the main memory in which the actual operand is available. String addressing. Now, to understand string addressing, let us recall the string operations. Let us understand the string operation. Let us say you want to compare two strings, whether those are equal or not. For that, we do require two strings. You know that in the 8086, we do have 4 segments of main memory. One is code segment. Second one is data segment. Third one is stack segment. The fourth one is extra segment. All these segments are going to get supported by the segment registers. ES register, SS register, DS register, and CS register. In addition to these registers, we do have 2 more registers. One is SI and one more is DI, source index and destination index. Let us understand about all these registers in order to understand what is the string addressing mode within the 8086. When you perform a string operation, 2 strings must be compared. Let us understand. The source string will always be available in data segment. Destination string, which is the second string, will always be available in extra segment. This data segment is going to hold the base address of the data segment. Let us say code segment is starting from 100. This is from 1000. This is from 2000. This is from 3000. These are the starting addresses, are the base addresses. When it comes to the SI and DI registers, they are going to hold the offsets of source operand and destination operand. Source operand offset is, let us say, 45. Destination operand offset is, let us say, 56. Now, in order to calculate the exact address in which source operand is available and the destination operand is available, we will add the source index register value to the DS register. At the same time, we're going to add the destination index register value to the ES register. Okay. So it is quite evident that what is the data segment register value? 1000. 1000 plus 45. In 1045th location, you do have the first operand, that is source operand. Again, what is the extra segment register value? That is 3000, because the extra segment is getting started from 3000. 3000 plus 56 is equal to 3056, in which the destination operand is available. That is, the destination string is available. The source index, rather source operand is available at 1045. Destination string is available at 3056. So at 3056, string 2 is available. At 1045, string 1 is available. After calculating the effective address, we will be able to get these two strings, S1 and S2. Then the comparison will be performed. This is all about string addressing modes. Once again, let us have a recall completely. 8086 has been divided into, main memory has been divided into 4 segments: CS, DS, SS and ES. All the base addresses of these segments are stored respectively in CS, DS and SS and ES registers. When you want to perform a string operation, there will be two operands. One operand is available always in the data segment. One more operand is always available in the extra segment. Offsets will be calculated for these operands as follows. In order to calculate, effective addresses will be calculated for these operands as follows. Data segment register value should be added to source index in order to calculate the effective address of the first operand, that is the source operand. Destination operand, which is the second operand, effective address will be calculated as ES register plus DI register, after which we'll be able to locate those two operands. Finally, we are going to get these operands, then the comparison will be made. The operation can be performed. This is all about string addressing mode. Employed string operations 2 operate on string data. The effective address EA of source data is stored in SI register and the EA of the destination is stored in the DI register. Segment register for calculating the base address of the source data is data segment, and that of the destination data is extra segment. That is what we discussed. Okay, this is exactly going to depict the operation that I have shown you just a short while ago in order to calculate the effective address. Port addressing modes. What are the different port addressing modes? When you want to make a transfer from one of the IO devices to the CPU, we are going to use the port addressing mode. Here, in AL,09H. What is in? In is an input instruction. When you use in, a character will be transferred from the input device to the accumulator lower byte. For that, the port address must be specified. What is a port address? Port address is an address to which the keyboard has been connected. Actual peripheral device has been connected. This is what direct IO port addressing or an indirect IO port addressing. In the indirect IO port addressing, this address will be specified in a register. I'll show you here. In the indirect addressing mode, the address will be specified within a register. The instruction will specify the name of the register which holds a port address. Here in this case, DX. The contents of the accumulator will get transferred to the port address which is held by DX register. This is the difference between direct IO port addressing and indirect IO port addressing. Relative addressing mode. In the relative addressing mode, already you know that the contents of the program counter will be added to the value which is given in the instruction. Let us say the current instruction is 22, in which we do have an instruction that is add 250. As the current instruction is 22, the program counter value will be equal to 23. 250 plus 23 is equal to 273 is the actual effective address in which the operand is available. This is how program counter value will be added to the value which is specified within the instruction. 0AH, which is the value which is given in the instruction, should be added to the program counter's value. When it comes to the implied addressing, we are provided with neither an operand nor a processor's register nor a memory location. Instruction itself contains the actual operand. You know that when you have a look at the CLC is not supported by any of the operands, either followed by or preceded by. CLC is a single instruction which is not supported by any operand at all, but CLC itself, it contains the operand. What is CLC? Clears the carry flag. Carry flag within the computer system will be cleared to 0. This is all about implied addressing mode. In the implied addressing mode, the instruction itself, it is going to contain the actual operand. Operands can never be specified explicitly. These are the several addressing modes which are supported by the 8086 architecture. But for this, you need to have an idea about the generic addressing modes which were covered in one of the previous sessions. Thank you.